Good to see you again. I call myself Mr. U.S. Patil, working as assistant professor at Sharad Institute of Technology, College of Engineering at RAW, Chalkanji, which is at Kolhapur district, Maharashtra. Today we're going to see a surface modeling. So let's get started with the surface model. The surface model represents the skin of an object. These skins have no thickness or material type. The surface models define the surface features as well as the edges of the objects. A mathematical function describes the path of the curve or parametric techniques we can use. Surfaces are edited as a single entities. Here in a wireframe models are unable to represent complex surface of an object like car, ship, airplane, wings, casting, etc. Only a surface model can be used to represent the surface profile of these objects. Also, a surface model can be used for calculating mass properties and interface between parts for generating cross-sectional views, finite element mesh, and NC toolpaths for the continuous path machining. Additionally, a surface model can be used for fitting experimental data or uh, you can say that discretized solutions of differential equations, construction of purpose surface, or sorry, pressure surface, construction of stress distribution, etc. The surface creations on CAD system usually requires wireframe entities, line, curve, points, etc. All analytical and synthetic curve can be used to generate surface. In order to visualize the surface on the graphical display, a mesh, say m into n in a size usually displayed. Uh, the mesh size is controlled by the user. Most of the CAD systems provides option to be set the mesh size. A surface model of an object is a more complete or less ambiguous representation than its wireframe model. It also richer in its associated geometrical contents, which makes it more suitable for engineering and design applications. A surface model can be used, for example, to drive the cutter of a machine tool, while a wireframe model cannot. The surface model take the modeling of an object one step beyond wireframe models by providing information on surfaces connecting the object edges. Typically, the surface model consists of wireframe entities that form the basis to create surface entities. The surface description is usually tackled as an extension to the wireframe representation. The analytical and synthetic surface entities are available and provided by most CAD/CAM systems as well. The surface modeling has been developed rapidly due to the shortcoming and inconvenience of wireframe modeling. The former is considered an extension of the latter. In general, wireframe model can be extracted from a surface model by deleting or blanking all surface entities. A database of surface models are centralized and associative. Thus, manipulating surface entities in one view is automatically reflected in other views. These entities can also be subjected to three-dimensional geometrical transformations. Despite their a similar look, there is a fundamental difference between surface and solid models. The surface model defines only the geometrical of their corresponding objects, and they stores no information regarding the topology of these objects. Now, The major surface entities provided by CAD/CAM systems are plane surface, ruled or lofted surface, tabulated cylinder, surface of revolution, Bezier surface, B-spline surface, Kuhn's patch, fillet surface, and offset surface. So if you see a plane surface, this is the simplest surface, require three non-coincidental points to define an infinite plane. The plane surface can be used to generate cross-sectional view by intersecting a surface or solid model with it. And it generates cross-sectional for mass property calculation or other similar applications where a plane is needed, right? This is what one plane and multi-plane you can see here. This is what plane surface. And this ruled lofted surface, there is ruled lofted surface. This is the linear surface. It interpolates linearly between two boundaries curves that defines the surface, that is called rail. Rails can be any wireframe entity. This entity is deal to represent surface that do not have any twists or nicks, right? This entity is ideally to represent surface that do not have any twists or nicks. Here surface revolutions or surface revolution, this is an axisymmetric axisymmetric surface that can model axisymmetric objects. It is generated by rotating a planar wireframe entity in a space about the axis of symmetry of certain edge. This is of axis of rotation, right? And next one is the tabulated cylinder. This is a surface generated by translating a planar curve a certain distance along a specified direction, that is axis of the cylinder. As you can see here, the plane of the curve is perpendicular to the axis of the cylinder. It is used to generate surfaces that have identical curved cross section. The word tabulated is borrowed from the APT language terminology, that was one language of APT. So this is what a tabulated a cylinder. Next we can see a Bezier surface. This is a surface that approximates a given input data. It is different from the previous surface in that it is a synthetic surface. Similarly to the Bezier curve, it does not pass through all given data points. It is a general surface that permits twists and nicks. The Bezier surface allows only global control of the surfaces. This is what one example of Bezier surface. B-spline surfaces. B-spline surface, this is a surface that can approximate or interpolate a given input data. It is a synthetic surface. It is a general surface like the Bezier surface, but with the advantage of permitting a local control of the surfaces. These are the data points and this is a B-spline surface. And next is the Kuhn's patch. Above all surfaces are used with either open boundaries or given data points. The Kuhn's patch is used to create a surface using curves that form closed boundaries, that forms this closed boundary. And next one is this fillet surface. This is a B-spline surface that blends two surfaces together. The two surface may or may not be trimmed. This is you can see easily in this picture. Next one is offset surface. The offset surface in existing surface can be offset to create new ones identical in shape but may not have or may have different dimensions. May or may not have different dimensions. It is useful surface to use to speed up surface constructions. For example, to create a hollow cylinder, the outer of the inner cylinder can be created using the cylinder command, and the other one can be created by the offset command. Offset surface commands becomes very efficient to use if the original surface is a composite one. This is what one example of offset surfaces. This one surface again offset of again this of surface, you can change the uh, dimensions of this. Only the offset is important here. A multi offset surface is required if you can do this. If surface presentation method, what are the surface representation methods? The two types of surface are commonly used in modeling, that is parametric and implicit. And the parametric surface are defined by a set of three functions, one for each coordinates as shows in below. That is f of uv, that is x of uv, y of uv, and z of uv, where parameter of u and v are the certain domain. We shall assume that both u and v are the range of 0 to 1, and thus uv is a point in the square defined by 0 0 1 0 0 1 and 1 1 in the uv coordinate plane. And implicit surface is defined by polynomial of three variables. You can say p of x y z, that is equal to 0. The surface which have polynomial implicit form are called algebraic surfaces. These highest degree of all terms is the degree of the algebraic surface. Therefore, the sphere and all quadratic surfaces are algebraic surfaces of degree 2. The following equation shows the degrees three algebraic surfaces whose implicit equation is 8x square minus xy square plus xz square plus y square plus z square minus 8. This is what overall uh, explanation about a brief explanation of surface modeling. We'll see in. And what about this surface modeling? Some advantages and disadvantages are, even though you see advantage estimates ambiguity and non-uniqueness present in WFM, the wireframe model. Renders the model for better visualization and presentation. The objects appears more realistic, right? And provides the surface geometric for CNC machining, provides the geometric needed for mold and die design, can be used to design and analyze complex free-formed surfaces, that is ship hulls, airplane wings, and car bodies. The surface properties such as roughness, color, and reflectivity can be assigned and demonstrated. The disadvantage is only the surface model provides no information about the inside of an object and cannot be used for calculating a dynamic properties. So this is what overall explanation of surface modeling. So we'll see you soon. in the next video as well. Thank you.